Maybe you know. Science meets the questions you never thought to ask. It's 3:17 a.m. You wake up. Your eyes are open. You can see the ceiling, the window, the sliver of light under your door. And there's something in the room with you. It is standing at the foot of your bed. You try to scream. Nothing comes out. You try to lift a finger. Nothing moves. And the thing, whatever it is, takes one slow step closer. For as long as humans have written things down, we've been writing about this. In Newfoundland, they called her the Old Hag, a woman who climbed onto your chest while you slept. In Japan, kanashibari, meaning bound by metal. In Scandinavia, the Mara, and yes, that word is where the English word nightmare comes from. In Turkey, karabasan. In Mexico, ese me subió el muerto, the dead climbed on top of me. Different countries, different centuries, different languages, but the same story. You wake up. You can't move. Something is in the room. In 1664, a Dutch physician named Isberen van Diemerbroek wrote down one of the first medical case reports of what we now call sleep paralysis. His patient was a 50-year-old woman who told him that night after night, the devil came and sat on her chest, and she couldn't push him off. Van Diemerbroek didn't know what to make of it. For the next 300 years, neither did anyone else. It was a haunting, a possession, a witch riding you in the dark. And then, in the 20th century, neuroscientists looked at the brain and found something far stranger than a demon. In 1959, a French neuroscientist named Michel Jouvet was working with cats. He had noticed something odd about a phase of sleep where the eyes flickered rapidly behind closed lids. We now call it REM sleep. Jouvet wanted to know what kept the body still while the brain was clearly active. So he did something a little brutal. He made tiny lesions in a region of the cat brainstem called the pons. What happened next was unforgettable. The cats fell asleep. Their eyes started moving. And then they got up. They walked. They pounced on invisible mice. They arched their backs and hissed at things that weren't there. They were dreaming and acting out the dreams, eyes still closed. Jouvet had just discovered REM atonia. During REM sleep, the brain sends a signal down the spinal cord that paralyzes nearly every muscle in your body. It's a safety lock. Without it, you'd kick, swing, run, and fall out of bed every single night. With it, you can have the wildest dream of your life and never twitch a finger. But every safety lock has a failure mode. And sometimes the lock doesn't open when you do. Here's what happens on a normal night. As you fall into REM sleep, two clusters of neurons in your brainstem, the sublateral dorsal nucleus and the ventromedial medulla, flood your motor neurons with two neurotransmitters, glycin and GABA. Think of them as door locks slamming shut on every muscle below your neck. Your diaphragm keeps moving so you can breathe. Your eyes still flicker. Everything else, frozen. When morning comes, your brain runs the sequence in reverse. The lock's open. Consciousness comes back online. You stretch, yawn, get out of bed. The handoff is so smooth, you never notice it's happening. Sleep paralysis is what happens when that handoff misfires. Your conscious mind boots up early. The lights are on. The eyes work. The memory is awake. But the locks haven't released yet. The glycin is still pouring in. So your body is biologically still in the dream state, while your mind is fully in the room. Imagine waking up inside a car where the engine starts, but the doors are still bolted shut from the outside. That's your brainstem still running its night shift. And the thing about that car, it's about to fill with something else. Because here's where it gets strange. The hallucinations aren't random. A psychologist named J. Alan Shane at the University of Waterloo spent over a decade collecting reports from thousands of sleep paralysis sufferers around the world. He wanted to know, when people see things during these episodes, what do they actually see? What he found was unnerving. The hallucinations cluster into three categories, and almost everyone, regardless of culture, has one of them. Type 1, the intruder, a felt presence in the room. Footsteps, a shadow, someone breathing near your bed, the sense that you're not alone. Type 2, the incubus, pressure on your chest, hands at your throat, a weight pressing down so heavy you can't draw breath. People often think they are dying. Type 3, the vestibular motor, floating, flying, spinning, falling, the feeling that you have left your body, the classic out-of-body experience. A Newfoundland fisherman in 1834 and a college student in Tokyo in 2024 will describe the same three things. The shapes change. The script doesn't, which means whatever is haunting humans at 3 a.m., it's coming from inside the brain itself. In 2011, a Penn State psychologist named Brian Sharpless and his colleague Jacques Barber pulled together every reliable study they could find on sleep paralysis. They reviewed 35 studies covering 36,533 people across multiple countries. The numbers were larger than anyone expected. About 7.6% of the general population had experienced at least one episode of sleep paralysis in their lifetime. Among college students, that number jumped to 28.3%. Among psychiatric patients, especially those with PTSD or panic disorder, it climbed to nearly 32%, roughly 1 in 3. Translate that to a country. The United States has about 333 million people. That means more than 25 million Americans have woken up at least once unable to move with something in the room. They just don't talk about it. Shane's group at Waterloo went further. They found the average episode lasts between 6 seconds and 2 minutes, but inside the experience, it always feels longer. One participant said 3 minutes felt like 40. The amygdala, the brain's fear center, fires at full intensity. Time stretches, reality bends, and then, mid-episode, something even weirder starts to happen. In 2013, a Cambridge neuroscientist named Balan Jalal ran a study comparing two groups, 100 students in Cairo, Egypt, and 50 students in Aalborg, Denmark. He asked them about their sleep paralysis experiences in detail. The Egyptian students reported episodes nearly 3 times more frequently than the Danes. Their episodes lasted longer. They were more terrifying, and nearly half of them, 48%, believed the cause was supernatural. A jinn, a spirit, an entity attacking them. The Danish students, by contrast, mostly thought of it as a brain glitch. A weird sleep thing. Annoying, but not haunted. The data showed something startling. The more you believe sleep paralysis is supernatural, the more often it happens to you, and the worse it gets. Belief feeds the loop. Fear of the demon summons the demon. The brain, primed to expect a threat, generates one, and the amygdala lights up like a Christmas tree, dragging the episode out longer. Which means the figure at the foot of your bed is not just a hallucination. It is a hallucination shaped by every horror story you've ever absorbed, every culture you grew up inside, every fear you carry into the dark. Here's what science actually knows about preventing it. The strongest predictor is sleep position. People who sleep on their backs are roughly 4 times more likely to experience an episode than side sleepers. Why? Probably airway compression and an increase in respiratory irregularities during REM. Rollover. The second predictor is sleep deprivation. Pull an all-nighter, then crash hard, and your body floods you with extra REM to make up for what you lost. More REM means more chances for the handoff to fail. Stick to a regular schedule, 7 to 9 hours. Same time every night. The third is stress and anxiety. They prime the amygdala. They make every episode worse. Mindfulness training, in a 2020 trial led by Balan Jalal, reduced sleep paralysis frequency by roughly 50% in participants who practice meditation, focused breathing, and emotional distancing during episodes. And there's a piece of folk wisdom that turns out to be real. Try to wiggle one toe, or one finger. The peripheral muscles often unlock first. Once one digit moves, the chain reaction breaks the paralysis fast. The fishermen of Newfoundland figured that out a century before the neuroscientists did. It is 3:17 a.m. You wake up. Your eyes are open. There's a figure standing at the foot of your bed. Now you know what it is. Is your own brainstem still running the night shift? It is glycine, late by 90 seconds. It is your amygdala on full alert, painting a threat onto the empty air, because every human brain, in every century, in every language, fills the silent dark with the same shape. Something watching. Your ancestors called it a demon. Van Diemerbroek called it the devil on the chest. Juvic called it failed autonia. Sharpless called it parasomnia. It's all of those, and none of them. The thing in the room is not in the room. It is, and always was the visitor your own mind sends when consciousness arrives at a body that hasn't yet been unlocked. Tonight, somewhere on Earth, 20,000 people will meet it again, and in the morning, almost none of them will say a word about it. If your brain can manufacture a stranger at the foot of your bed, what else is it doing while you sleep? Next week, we open up lucid dreaming. The people who learn to wake up inside their dreams, take control, and walk through the door. One Stanford lab has been measuring it since 1980, and the findings are stranger than the dreams themselves. Thanks for watching. If this sparked a question, drop it in the comments. It might be our next video. We'll see you next time.